Hello students, let us continue the 11th part of Unit 4 Chemical Bonding and Molecular Structures. In the previous class we discussed bond parameter of resonance structure, and now we discuss about one more last polarity of bonds. Okay, so polarity of bonds. Bond means, especially we take a covalent bond. Okay, covalent bond. How did you form of covalent bonds? Covalent bond is a sharing of electrons. Okay, already you know it. But what about ionic bonds? Ionic bond means they loses the electrons, get cations and gaining of electrons to forming of anions. Both were in the force of Coulombic force of attraction to get bond. That is called ionic bond. Listen, ionic bond, it is not completely oriented to the ionic character. It is some of the partial covalent character also present. In a covalent bond, some ionic character also present. Okay, those we'll discuss in the next class. So now going to the polarity of bonds. Same molecules in we take of a bonds, covalent bond. Two atoms each were sharing one electron to forming of single bond. Two electrons share to forming of double bond and so multiple bonds. Okay. So we take covalent bond like homonuclear atomic molecules. Homonuclear atom means same atoms. Like example, so here X and X, H2 molecule. So how they share each of the electrons. Then F2 molecule, Cl2, N2 and O2. Okay. So F2 also same. So let us select 1, 2, 3, 4, 5, 6, 7. Okay. Chlorine also same. Valence electron is 5. So nitrogen 1, 2, 3, 4, 5. One more nitrogen is 1, 2, 3, 4, 5. So this is to get triple bond. Oxygen 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oxygen carries. But you take only the concept of homonuclear atoms. Homonuclear atoms, same atoms. Okay. So in this type of condition will form. Did you identify the charges? This is carries a positive charge. This is carries negative charge. Doesn't appear the electronegative because they have similar electronegative nature. So this is called non-polar covalent bond. Okay. Definition of non-polar covalent bond is the covalent bond in which the atoms having electronegativity are equally attracted with respect to each other is called non-polar covalent bond. Okay, so what is said, the covalent bond in which the atom having the same electronegativity. We did not identify this positive, this is negative, because those were homo atoms, same atoms. So which can respect to each other. Those type of atoms were joining to get the bond formation, sharing of electrons. They get single bond and multiple bond also. Those were all called non-polar covalent bonds. What about polar covalent bond? So different electronegativity, such as example like we take the HCl, HL. Okay. So they have the H and L. See here, the H atom, the partially less electronegative than compared to the fluorine. The H atom is in the left side, the fluorine is in the electronegative, high electronegative nature. It's a p black element. So the fluorine atom carries partially negative charge, hydrogen is partially positive charge. Okay, different electronegativity. Okay, what's the definition of polar covalent bond is? The covalent bond in which shared pair of electron between the two different atoms gets displaced more towards high electronegativity atom induced the polarity. Okay, this is called what? Polar covalent bond. This is what? Which share the electron pair of same electronegativity between the same atoms. But in the case of shared pair of electron or electron pair between two different atoms, this is two same atom, gets displaces more towards the electronegativity. In this atom, this is more towards the electronegative atom. This is called what? Polarity is formed. The polarity we symbolically we represent in the symbol like this. Okay, it's indicated this symbol of polarity, crossed arrow. Okay, the crossed in the positive end. Okay, so positive end, how did you write? This is a positive end. Okay, this is a, because this is positive atom. So this is what? Arrow head in the negative end. So it look like here. This is what? Negative end. Okay, clear? So very simple. Non-polar, don't get confused. Polar is same, non-polar is different. Your mind was thinking like, but polar covalent bond means different atoms. It's a polar bond. Different electronegative atoms. Non-polar covalent bond means similar electronegative atoms are present. Clear? Okay. So now going to representation of polarity in dipole moment. Okay. So dipole moment. So one of the vector quantity. So it is represented in a mu. Okay. So polarity we calculated one of the method of dipole moment. Okay. Only the polar covalent bond molecules will give polarity. So because of different electronegative, they get the values. The values is calculated by using the dipole moment. The dipole moment is one of the vector quantity. So dipole moment. It is symbolically mu. Say mu. Pronunciation. Okay. The definition of dipole moment is the product of magnitude of charge and the distance between the centers of positive and negative charge, distance, okay, the distance. So we represent dipole moment. This representation in mu. So what is charge? Okay, into distance of separations. Distance of separation. Okay, so representation is q, charge. The distance of separation is r. So charge between positive and negative charge and distance. It's a representation of radius. Okay. So unit of dipole moment is, the unit is, say, Debye, D-E-B-Y, Debye. So 1 Debye means the value is 3.3564 into 10 to the power of minus 30 coulomb meter. This is coulomb. It's meter. Okay. This is the values of 1 Debye value. 3.33564 into 10 to the power of minus 30 coulomb meter. Okay. So now look at some example to value of dipole moment. So HF, HCl, HBr, HI, the value is 1.78 dBu, 1.07 D, and 0.79 and 0.38. Okay. So just see, this is the value of dipole moment. This is the lower molecules. This is what the term is indicated. In this place, the lower electronegative atom is present. Here, higher electronegative. So this is indication moving towards the lower electronegative to higher electronegative. See here, this is the example: HF, HCl, HBr, HI. So this is all are same H atom. Only concentrate of this fluorine, chlorine, bromine, iodine. Already you know that the fluorine is high electronegative than compared to the chlorine. Okay, the fluorine is high electronegative than compared to Cl. This is less this is more electronegative than Br. The Br is more electronegative than iodine. Okay, this is the highest value because high electronegative nature. Then HCl is 1.07. This is less electronegative than fluorine. So automatically the value will be less. So on bromine and iodine. Iodine is least electronegative nature. This value is 0.38. Okay. So just knowing about some other examples. Dipole moment is very important. We'll ask examination. The definition and unit 1 marks. Either directly we'll ask what's the unit of dipole moment. Okay, unit is okay. See here, it's one of the example of just two atoms, diatomic molecules. Here only consider heteroatoms, not be homoatoms, because similar atoms doesn't appear on any charges. Clear? So heteroatom of 2. Example to given HF, HCl. These are the heterodiatomic molecules will give obviously 1.78. So some of the values of dipole moment. But we know about some polyatomic molecules. Polyatomic molecules means more than two atoms. More than two atoms presence. What's the nature? They make, this is a vector quantity. Already I said the dipole moment is a vector quantity. Vector means vector quantity. So vector quantity, it's mean in this case of two values, they make cancel each other. They get values to be, some of the values to get 0 also. This is what the net dipole moment. We'll look up for some of the example of polyatomic molecules. Polyatomic molecule, more than two atoms. Polyatomic molecule. Say one of the type is AB2 type. Okay, so example one is beryllium fluoride. See here, this is a beryllium, this is center. Say fluorine is in the corner side. Okay, this is one of the linear type of structure. Okay, so now the important point is, this is a arrow marks, the symbol you just mentioned, the polarity you did observe. So beryllium and fluorine. So beryllium is less electronegative than fluorine. Okay, so beryllium observe ಮಾಡಿ periodic table ಅಲ್ಲ. So beryllium, just you have to imagine, the beryllium is less electronegative than fluorine. Fluorine ಗೆ ಜಾಸ್ತಿ electronegative ಇದೆ, beryllium ಗೆ ಕಡಿಮೆ ಇರುತ್ತೆ. So ಕಡಿಮೆ ಇದೆ ಅಂದರೆ this is carries what? In this symbol, this is arrow mark. This is a crossed head. This is more electronegative nature because of this is having a negative, this is positive, this is negative. So here also move towards like this. So vector quantity, the twos of the bonded, the vector, sum of the vector values, these two values, sum of vector quantities, this is added over to get dipole moment is cancelled each other. The two values will be summed. This is across over to get the opposite sign. They may cancel each other. Right? This is called what? The one is a dipole moment. The polyatomic molecule will set net dipole moment. The net dipole moment of beryllium fluoride is 0 because the values were cancelled each other. We observe in X-ray diffractions, spectroscopic method, we get this absorption of values. Net dipole moment is 0. So one more example is beryllium chloride also. Okay, same thing will happen. Beryllium, chlorine. So the beryllium is less electronegative, the chlorine is more electronegative. So make cancel each other, net dipole moment is 0. Okay, we'll take other one of the example of water. Okay, the structure will represent the structure. This is containing how much? 104.5 degree the bond angle. So now going to define about polarity. Polarity is going towards the high electronegative nature. So hydrogen, oxygen, hydrogen. So polarity is moving towards the oxygen having the lone pair of electrons. Don't forget the presence of lone pair of electrons. It's attract the electrons. Okay. The polarity is moved, high polarity increases. So here, this is hydrogen less electronegative, kadme electronegative ಇದೆ hydrogen. So oxygen more electronegative ಇದೆ. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ, hydrogen ಇಂದ electrons ಯಾವ ಕಡೆ ಮೂವ್ ಆಗ್ತವೆ, oxygen ಕಡೆ ಮೂವ್ ಆಗುತ್ತೆ. This is less electronegative, this is high electronegative. Okay, so in the presence of lone pair of electrons, so here observe, this is cancelled to each other. The values will be cancelled, but in this position, okay, in this case, the hydrogen atom, here of hydrogen atom, two hydrogen atoms, will moving towards the oxygen atoms, and presence of lone pair of electrons, it will be give what? The dipole moment is not cancelled. It is move towards the net dipole moment. So it will be happens. The net dipole moment is 1.85 d boy. So this is the one of the interesting thing. The values of two opposite signs is cancelled each other. This is over across the oxygen atom. They make what? The net dipole moment is given 1.85. Okay, this is not cancelled. Clear? So here one of the value is d boy. This is convert. Convert means 1 d boy means this is the values. Okay, so now you write conversion of net dipole moment. The water, say how much of value? 1.85 into d is 3.33564 into 10 to the power of minus 30 coulomb meter. Okay, so overall we calculated this value is 6.17 into 10 to the power of minus 30 coulomb meter is the net dipole moment of water. 6.17 into 10 to the power of minus 30 coulomb meter. Either you write 1.85 d boy. This is also right. This is also right. Okay, students, it's clear. Okay. Take one more example of this is 2 plus 1. Say triatomic molecule. Okay, we'll take the AP3 tetra atomic molecules. Okay, so tetra of example is BF3. Boron trifluoride. So here boron is the center. On the corner of each corner carries 3 triangular fluorine atoms. Okay, so now you think boron is 5 is the atomic number and fluorine is 9 atomic number. The boron is less electronegative than compared to fluorine. So boron to moving towards the fluorine. It's also boron to fluorine, boron to fluorine. Okay. So in this case, see here the structure, the vector quantity, sum of all these values to cancel each other because there is no any lone pair of electrons and the values were cancelled each other. CC's make the dipole moment is become 0. This is tetra molecule. Okay, so interesting thing, one more. One more. Say NH3 and NF3. Okay, see here NH3 molecule. Say nitrogen is a central atom. Okay. Say this is one of the H, here X, here X. Say free radicals. Nitrogen having 3 bond pairs. Okay, students, in ammonia, NH3, see here, nitrogen of valence electron is 5. In that 5, 3 were attracted H. Okay, and remaining 2 valence electrons, this is called water, lone pair of electrons. One lone pair of electrons. It will be represented like this. Okay. Now see, this is the structure of ammonia. So you write what polarity? Polarity is, this is hydrogen less electronegative, so nitrogen is more electronegative. So this is moved towards like this. This is also same. Okay. So all the three bonded atoms moving towards the nitrogen atom. The nitrogen atom had having one lone pair of electrons. Lone pair of electrons also involving in one character sees the formation of moving towards like this. Okay. So make the values of net dipole moment is not cancelled because they have in the presence of lone pair of electron, and this is increases the values, and the net dipole moment is 4.90 into 10 to the power of minus 13 coulomb meter. But in the case of NF3 molecules, nitrogen is the central atom, say fluorine, so one more fluorine, say fluorine. C is your lone pair of electrons. The lone pair of electrons is like this. Now you see, very interesting. Here, the fluorine atom, but in the case hydrogen atom is less electronegative. But in this place, fluorine atom is present. Fluorine and nitrogen. Nitrogen is less electronegative. Nitrogen is less electronegative. The fluorine is more electronegative. So, in that type of case, the nitrogen is less electronegative. This is a crossing. This is an arrow-headed in the fluorine atom. This is nitrogen is moving towards the fluorine atoms. Okay. In the case of lone pair also involving. This is nitrogen of lone pair of electron also move towards the fluorine atom. This make the values is less. The dipole moment, the net dipole moment not cancelled because they have not opposite same. This is all going in the same directions. So is 0.8 into 10 to the power of minus 30 coulomb meter. Okay. See here, this is the value is 4.90. In this case, 0.8. This is very small amount of values. Why? Because of, in the case of NH3, because in the case of NH3, the lone pair in the same direction of NH bond, so make increases the dipole moment, whereas in the case of NF3, the lone pair in the opposite direction, the orbital dipole of lone pair in opposite direction, so season decreases, the dipole moment value is decreases. Clear? This is the polarity of bonds. Very important thing of in this concept, dipole moment. What is dipole moment? Dipole moment unit, and these type of examples anyone will be asked. Okay? So write the dipole moment or explain the dipole moment of NH3 water molecules anyway. Okay? Clear? So net dipole moment is 0. 1, say cancel each other, the values should give 0. But lone pair of electrons are present. In this type of values is net dipole moment is not 0. Okay? Understand? Okay. Thank you.